Integration by parts is a technique of integration whereby we integrate product of two functions, that is f of x times g of x dx. And these two functions can be a function of logarithm, a function of logarithms, can be a function of algebraic equations, function of algebraic equation, function of inverse trigonometric function, can be a function of exponential functions, It can also be a function of trigonometric functions, So integration by parts is employed to integrate a product of either two of these functions or more. So integration by parts formula is given by integral of f of x gx dx is equal to f of x times integral of g of x dx minus the integration of differentiation of x, product of differentiation of f of x times the integral of g of x dx. And this equation can also be written as u integral of u v dx being equal to u integral of v dx minus integral of the derivative of u times the integral of g of x, that is v dx dx. So let's look at an example. When you are integrating a product of two functions, f of x and g of x dx, and these two functions two or more functions can be logarithmic function, can be inverse trigonometric function, it can be algebraic function, it can be exponential functions, it can be trigonometric function, logarithmic function, inverse trigonometric function, algebraic function, exponential function, or trigonometric function. Now, the integration by parts formula is given by integral of f of x times g of x dx being equal to f of x times integral of g of x dx minus integral of the derivative of f of x times integral of g of x dx, again dx, which again can be written as u integral of u v dx being equal to integral of u times integral of v dx minus integral of the derivative of u times integral of v dx. Again, this formula can also be written as integral of u dv being equal to uv minus integral of v du. So integration by parts are given by two formulas. The first formula is f of x, integral of f of x times g of x times integral of f of x g of x times dx is equal to f of x times integral of g of x dx minus integral of derivative of f of x times integral of g of x dx, which is same as integral of uv dx, which is equal to u times integral of v dx minus integral of u prime times integral of v dx, again, which is also can be written in this form. The integral of u dv is equal to uv minus integral of v du, where u is the first function, and v is the second function. Now, when choosing u or v, we need to look at the order in which the functions appear. For instance, you need to employ the idea of light, which means this one's logarithmic equation. This means inverse trigonometric equation or function. This algebraic function. This is trigonometric function, and this is the exponential. This function is the exponential function. Now you need to choose your u in this order, which means if logarithmic function appears before inverse trigonometric function, then u is supposed to be logarithmic. If logarithmic function appears ahead of inverse trigonometric function, then u becomes logarithmic function. If trigonometric function appears before exponential function, then your u becomes trigonometric functions. So let's see an example. Find the integral of x squared exponential x dx. Now the formula for integration by parts given by integral of u dv is equal to uv minus integral of v du. Now we need to employ the technique of or the idea of light, which means that logarithmic, this means that this logarithmic function is inverse trigonometric functions, algebraic functions, trigonometric functions, exponential functions. Now if you look at our integral, we have x squared. X squared is algebraic functions. E raised to power x exponential functions. Now our u becomes x squared because x squared comes before exponential functions, and therefore we let u to be x squared. U is equal to x squared. If u is equal to x squared, our dv will now be equal to exponential x dx. Now du dx, this side will be 2x. Our v will be the integral of exponential x dx, which is equal to exponential x. Now if we substitute in this formula, we have integral of u dv being equal to uv. U is x squared, v is exponential x, minus integral of v du. Our v is exponential x. Our du is 2x dx. 2x dx. Again, when we get here, we need to employ another integration by parts. Now, integration of exponential x, 2x dx. Again, our u becomes our u becomes 2x. Our v is exponential x dx, because 2x comes before exponential x. Now du dx will be 2. That is dv. Our dv is exponential x dx. Now v will be integral of exponential x dx, which is equal to exponential x. Our v is exponential x. Now if we substitute again in the formula of integration by parts, uv minus uv minus integral of v du, we'll have our u is 2x, our v is exponential x minus integral of v du, that is integral of exponential x du. Our du is 2 dx. Now this same as 2x exponential x minus 2 integral of exponential x dx, which is equal to 2x exponential x minus 2 exponential x plus constant term c. Now we need to substitute this one here. Now the integral of x squared exponential x dx will be equal to x squared minus x squared times exponential x minus in bracket 2x times exponential x minus 2 times exponential x plus the constant term c, which is equal to x squared times exponential x minus 2x exponential x plus 2 exponential x plus the constant term c, which can be simplified as exponential x in bracket x squared minus 2x plus 2 exponential x in bracket x squared minus 2x plus 2 bracket plus the constant term c. And that's the answer to the integration of x squared times exponential x dx. Find the integral of x sine 2x dx. Again, the solution to the problem, the formula of integration by parts is given by integral of u dv is equal to uv minus integral of v du. Now we need to choose u and v in this equation. Now using the idea of light, our u becomes, our x becomes x, because x is an algebraic equation, and the algebraic equation comes before trigonometric functions, which is sine 2x. So our dv is sine 2x. Now du dx is 1. Our v now will be integral of sine, that is dv is sine 2x dx. Our v will be sine 2x. Our v will be the integral of sine 2x dx. Now we know very well that the derivative of cos of x is minus sine x. The derivative of cos of 2x is 2 minus sine of 2x. And therefore, to make this one become, to make this one sine of 2x, which we have here positive sine 2x, we need to find the derivative of minus a half cos of 2x, which will be sine of 2x. Now the integral of sine of 2x dx is minus a half cos of 2x. So now that's the value of our v. Now if you apply the formula of integration by parts, integral of u dv is equal to uv minus integral of v du, we'll have our u is x, our v is minus a half cos of 2x minus integral of v du. Our v is minus a half cos of 2x du. Our du is 1 dx, that is dx. Again, this is same as minus a half x cos of 2x plus a half integral of cos of 2x dx. Again, to find the integral of cos of 2x dx, you know very well that the derivative of sine x is positive cos x and therefore the derivative of sine of 2x, will be 2 cos of 2x, but we need to have only cos of 2x. So it means that if you divide by 2, we'll have dx of a half sine 2x being equal to cos of 2x. So the integration of cos of 2x dx is a half sine 2x. So we have this equal to 1 over 2 x cos of 2x plus a half bracket. The integral of cos of 2x dx is a half sine 2x. A half sine 2x now plus the quotient term c. Now, the solution to that equation, to that integration, is half x cos of 2x plus 1 over 4 sine 2x plus the constant term c. That's the solution of the integration of sine x times sine of 2, integration of x times sine of 2x dx. Example 3. Find the integral of x natural log of x dx. The solution will be given by the formula of integration. Integral of u dv is equal to uv minus integral of v du. Now we need to choose our u and v appropriately using the idea of light, where L is the logarithmic equation, I is the inverse trigonometric functions, A is the algebraic function, T is the trigonometric function, and E is the exponential function. Now x is algebraic functions and ln is logarithmic function. ln x comes ahead of x, and therefore the natural log of x becomes our u. Our u is natural log of x. Our v du, our dv becomes x dx. Now our du dx is 1 over x. Our v becomes the integral of x dx, which is equal to x squared divided by 2. If you substitute in these equations, you have u, that is integral of u dv, will be equal to u. Our u is natural log of x. Our v is x squared over 2, x squared over 2, minus integral of v du, that is x squared over 2, our du is 1 over x dx, 1 over x. Now this same as this equal to x squared over 2 natural log of x minus integral of x over 2 dx, which again is same as x squared over 2 natural log of x minus a half integral of x dx, which is equal to x squared over 2 natural log of x minus a half x squared over 2 plus the constant term c. So again, this same as x squared over 2 natural log of x minus 1 over 4 x squared plus c. Thus becomes the answer to the equation integral of x times natural log of x dx.